All right, guys, it's me, Mrs. Cavanaugh. No more Mr. B. Sorry. But this is the way it goes. All right, so here are the notes for 5.1. I'm hoping that I have time in class to do this, but if not, you can get them from here. So if you look at the printed note, you can use the printed notes or you can just write what I'm writing. It's up to you. I'm taking it off the printed note. The rule we're going to be looking at, the different rules, and this is the table. We're going to do an explanation in words. Then an algebraic explanation. And then we'll do an example. And then I'll work through the problems that are on the notes. Okay? These are things you did in Algebra 1 already, so this is just going to be a quick review so that we can get into some of the Algebra 2 concepts. So, product of powers. Okay, when you multiply like bases, you add exponents. So that's in words. When multiplying like bases, you're going to add the exponents. You kind of do this without even thinking because you know that x times x is x squared. Well, that's x to the first times x to the first, so you're adding the two exponents together. If we were going to write this using algebraic explanation, it's x to the m times x to the n, common base, same base, so we would do x to the m plus n. Okay? If we were doing an example, it would be x to the 5th times x to the 7th, and that would equal x to the 12th. Okay, so that's product of powers. Okay, next, quotient of powers. If we're talking about division, when dividing like bases, I know how to spell. It's okay. You're going to subtract exponents. So for example, if we have x to the m over x to the n, that's division. So it'll be x to the m minus n. If we had it as x to the 7th over x to the 5th, that would be x squared. Okay? Negative exponents. Continue this. And again, I have at the beginning of this video on Canvas, you can find, so you can print out the empty notes and you can just add to it. Negative exponents. If the exponent is negative, you can move from the numerator to the denominator, and that'll make it positive. Or if it's in the denominator, you can move it from the denominator to the numerator. So for example, if we had something like 1 over x to the negative m, you can't give that as an answer. Now, I always kind of make this a joke, like we have an upstairs and a downstairs. And this x is in the downstairs bedroom and unhappy because he has a negative exponent. To make x happy, if you would move him to the upstairs bedroom, he would then become happy. Okay? If you had x to the negative n and that was in the numerator, well, that x is unhappy upstairs, so move him downstairs. And now all of a sudden, he's happy. We're really doing the reciprocal here. So if you really think about it like that, if we have x over y to the negative 1, that means nobody in that house is happy where they're located. So if you flip them around, everybody's happy. Okay, so let's do some number examples. 4 to the negative 3. You can either do it to the negative third first and get your answer, or you can just say, well, I know the answer is going to be in the denominator. 4 to the third is 64, but this number is unhappy in the numerator, so that's going to go in the denominator. Okay, if we had 1 over 3 to the negative 2, well, we know 3 squared is 9, but we can't leave them downstairs, so we put them upstairs. Now, you don't have to put the 1 here. You can if you want to. Okay, now last thing is power to a power, and then we'll do a couple examples for this unit. Power to a power. If we are going to take a raise a power, raise an exponent to an exponent, that's when you multiply exponents. Okay, so for example, if we have x to the m, that whole thing raised to the n, that's going to equal x to the m n. Okay, so x to the 5th raised to the 3rd would be x to the 15th. Okay, if you have any questions on that, feel free to talk to me about it. So let me do some of the example problems that are on the back side of the notes. I'm going to talk you through these. I do have an answer key for the homework, but not a video for the homework, so I'm going to go through these as quickly as I can. And we didn't do scientific well, we'll get to the scientific, we'll talk about scientific notation. So here's some example problems using those rules. And again, if you already know how to do these, you can fast forward through this and just watch as much as you need to. I'm going to try to make it clear for those who didn't quite get this the first time through in Algebra 1. So we have negative 2, a to the 3rd b, quantity times negative 5, a to the b to the 4th. Now here's what you need to think about. We really have a bunch of little multiplication problems. So we really have negative 2 times negative 5. Those can go together. I'm going to put the a's together, a to the 3rd times a, and then I can put b times b to the 4th. The reason I'm allowed to do this is the commutative property of multiplication, meaning when you change the order of multiplication, it doesn't matter. So all I did was switch the order here. So in the first parentheses, we're just multiplying. Negative 2 times negative 5 is positive 10. In the second parentheses, we're multiplying like bases. So we're going to add exponents. And you notice I just made that 1 visible. So that it'd be a to the 3rd, a to the 1st, that's a to the 4th. And then the same thing with the b's. I have b to the 1st and b to the 4th, so that's going to end up being b to the 5th. And that's your simplified answer. Number 2 is s squared over s to the 10th. And it says s cannot equal 0. We're always going to have to make allowances for the fact that we can never have the denominator go to 0. And the reason for that is we don't know what dividing by 0 means. And so it's undefined, and so we can't do a problem like that. So we always have to make sure, let the reader know we're not going to let s equal 0. Okay? In this case, we're dividing like terms. Now, I want to just show you this longhand. So this is what's really going on. We have 2 s's in the numerator, and now I have 10 down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What we're doing is canceling out because s over s is equal to 1. So that's just a 1. And s over s is equal to 1. Well, what are we left with then? Well, we're left with a 1 in the numerator. And 1, 2, 3, 4, 5, 6, 7. Oops, I'm missing an s. Should be 8 of them down there. 8 in the denominator. How did I know there were 8? Well, because I subtracted 10 minus 2. In your answers, you can never have your answers be a negative exponent. You need to move them up or down to change that. Okay. Number 3 is b squared to the 4th. Well, this is a power to a power. We just multiply exponents, so it's b to the 8th. Number 4 is negative 3c squared d to the 5th all raised to the 3rd. When there's parentheses around everything, that means everything's getting raised to that power. So negative 3 to the 3rd, c squared to the 3rd, and d to the 5th to the 3rd. So what does that mean? Well, that means negative 3 times negative 3, which is positive 9, times negative 3, which is negative 27. Power to a power, we multiply. Power to a power, we multiply. And that's how we get that answer. Okay. Number 5, we have negative 2a over b squared, all raised to the 5th. Again, what we're doing is we're raising everything to the 5th power here. Negative 2 to the 5th, a to the 5th, and then b squared to the 5th. And then following our rules. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is going to be negative 32. Power to a power, where there's a 1 here on that a, so it's really a to the 5th. And then power to a power in the denominator is going to be b to the 10th, and I just realized my answer key is wrong. Okay? Number 6. There's a couple ways to do number 6. I'll show you one way. X to the 3rd to the negative 4th. If you want to get rid of the negative right away, that negative means we really are dealing with this reciprocal, so we flip it over. Whoops, that's not right. Flipping it over would put an x in the denominator, and then we can just raise it to a positive power. So that would be 3 to the 4th, x to the 4th, and 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3 is 81 over x to the 4th. Okay? Next one gets a little more complicated, number 7, and then we'll do a really complicated one. We have negative 3 a to the 5th 5y over a to the 6y b to the 4th. Now this looks confusing, but you'll see those y's and the exponents don't really make any difference here. Okay, so everything's getting raised to the 5th power. So negative 3 raised to the 5th power. A to the 5y to the 5th power, all over a to the 6y to the 5th power, and b to the 4th to the 5th power. So if I were to do this, negative 3 to the 5th is negative 243. Then we have a to the 25th y, because power to a power we multiply exponents. And then in the denominator we have a to the 30th y, b to the 20th. Now I can separate this out like I was showing you in the beginning, so 243 doesn't have anything to go with it, times a to the 25th y over a to the 30th y times 1 over b to the 20th. Well, the only thing that's going to get simplified here is that 25 and y and 30y. And you have to ask yourself, do they end up in the denominator or the numerator? Well, negative 243 is in the numerator, it stays there. There are 30 y's in the exponent in the denominator, so that's going to leave us with a to the 5y in the denominator, and then b didn't have anything to go with. So that's my final answer for that one. Now number 8 is pretty complicated, so let's get going on this one. Number 8, 4a to the negative 3rd, there's a lot of ways to do this. B to the 8th over 2a to the 3rd, b to the 4th to the negative 3rd power. I'm going to do this first. I'm going to get rid of that negative on the outside. So I'm going to flip this whole thing over and write the reciprocal. So 2a to the 3rd, b to the 4th, all over 4a to the negative 3, b to the 8th, all that raised to the 3rd power. So that took care of that negative, okay? The next thing, I'm going to raise everything to the 3rd power. So 2 to the 3rd, a to the 3rd to the 3rd, and b to the 4th to the 3rd. There's a lot of, you could do this in a lot of different ways. And actually I did it 2 different ways. My answer key, I did it different than I'm doing it right now. 4 to the 3rd, a to the negative 3rd to the 3rd, b to the 8th to the 3rd. Okay, let's deal with the numerator. 2 to the 3rd is 8. A to the 3rd raised to the 3rd is going to be a to the 9th. B to the 4th raised to the 3rd is b to the 12th, because power to a power we multiply, right? In the bottom, we have 4 times 4 times 4 times 4. I hope I got this right. Oh, no, it's 4 times 4 times 4, which is 64. Okay? A to the negative 3 to the 3rd is going to be a to the negative 9th, and we're going to deal with that in a minute. Okay? And then b to the 24th. So now let's look at each piece separately like we did before. 8 over 64 times a to the 9th over a to the negative 9th times b to the 12th over b to the 24th. Okay, let's look at our 8 over 64. 8 over 64 is going to simplify to 1 over 8 because 8 goes into 64. Now watch what happens with the a's. We have an a to the 9th in the numerator, but we have a negative 9 in the denominator. Well, to make that a happy, we're going to put it up here and make it a to the 9th in the numerator. Okay, and I'm doing lots of steps here. You don't have to do them all. B to the 12th over B to the 24th. Well, where the B is going to end up? Well, there's more B's on the bottom. 12 of them will be canceled out, so we're left with 12 in the denominator. Now the A's, what do we do with like bases? If we're multiplying like bases, what do we do with the exponents? We add them. So 9 plus 9 is 18. B to the 12th is on the bottom and 8 is on the bottom. And so this is what all that mess simplifies down to. So all of that mess went there. Okay, one little thing left for this section is scientific notation. Let's switch colors. Scientific notation, as you'll see in the notes, it's for really big numbers or really small numbers. And you've seen this before. Remember, you're always going to have one number, a decimal, and then whatever after that, times 10 to some type of exponent, okay? The decimal, before the left of the decimal, can be any number from 0 or 1 to 9. Okay, we need a 1 to 9 there. All right, so let's look at, for example, A. A is 4,560,000. In case you don't remember, I'm going to explain this from the beginning. Some of you are going to be like, I don't need this. Okay, the decimal's on the end. It is a very large number, so we're going to have a positive exponent on the 10. We're going to move that decimal until we only have one number to the left of the decimal that's 1 to 9. And so there's a 4. And I'm going to write out 4.56 times 10, and then I'm going to count my jumps. 1, 2, 3, 4, 5, 6 jumps to the positive 6. That's how you do scientific notation with a very large number. With a very small number, like we have here, 0.0, and it looks like we have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 5 zeros, and a 9, 2. Now, if we're going from a very small number, the exponent's going to be negative. So again, we're going to move it, but this time we have to move it the other way. We're dividing by tens here until we have 1 to 9 to the left of the decimal. So that gives us 9.2 times 10, since we were dividing by tens to move the decimal, is going to be negative, and we're going to count our jumps. 1, 2, 3, 4, 5, 6 to the negative 6. Okay? Now, when you have to multiply or divide and then put it into, and they're already in scientific notation, that means you better give the answer in scientific notation. So for example, C. We have 5 times 10 to the third times 7 times 10 to the 8th. Now here's what you do. You just split it up again. You go 5 times 7, because remember, multiplication is commutative. You can change the order. And 10 to the third times 10 to the 8th. So let's see what we got here. 5 times 7 is 35, and we have 10 times 10 to the 11th. Now here's where people lose points. This is not in scientific notation. The reason is the whole number should be between 1 and 9. Well, it's 35, which means we have to move that decimal. The decimal's here. We have to move it one more place. So that means it's really 3.5 times, and we moved it one place to the left, meaning we took a bigger number and made it smaller, so we're multiplying, so that has to be a 12 there. Okay? Let's look at D. 1.8 times 10 to the negative 4th, and then 4 times 10 to the 7th. Scientific notation is the only time you leave negative exponents. When we're dealing in scientific notation, we leave negative exponents, okay? So again, I'm going to do 1.8 times 4 in my one group, and 10 times negative 4 times 10 to the 7th in my other group. Well, 1.8 times 4 turns out pretty nice. It comes out to 7.2. So that's already okay. We don't have to do anything with that. And then remember, when you multiply like bases, you add exponents. Well, negative 4 plus 7 is 3, so it's 10 to the third. That's that one. 2 more problems. E. 4.2 times 10 to the 5th over 3.9 times 10 to the 3rd. Okay? Again, I can split these up and make these multiplication problems like this, and then just follow my rules of exponents. My first thing is 4.2 divided by 3.9, and that's going to give us 1.076, which means we're in good shape. We don't have to do anything with that. And then remember, with like bases, we subtract exponents. So that's going to be 5 minus 3, so that's 10 squared. And that's already in scientific notation, so that one's done. Last one, 9.2 times 10 to the negative 3 over 1.7 times 10 to the 6th. Again, I'm really doing 9.2 divided by 1.7, and then I'm going to go 10 to the negative 3 divided by 10 to the 6. So 9.2 divided by 1.7 is 5.4. And then again, remember, the only place you can leave negative exponents is scientific notation. We really have negative 3 minus 6. Okay, because we're subtracting exponents because we're dividing. So that's going to be negative 9. Again, this is already in scientific notation, so we can leave it. If you have any questions, please let me know and we'll work on this.